Hey y'all, welcome to the Christmas edition of this week's Hip Hop History News. Today we're going to be covering a guy by the name of Daniel Bernoulli. His name sort of sounds like an Italian noodle, but let's just go with it. So, he was born in Basel, Switzerland in 1700. His mom came from a wealthy family and his father was a well-known mathematician, and here's a picture of him right here. And yeah, so that's him, and his dad was known to be like really strict with him and very impatient. So he was mostly taught math by his older brother, and his two brothers were also really good at math, and basically their entire family was mathematicians. So, his dad wanted him to become a businessman, but he wanted to be a mathematician. So there was like a little bit of a family argument here, and he ended up graduating as a medicine doctor when he was 21. But he was still interested in the secrets of the universe, and so he continued mathematics. He was interested in fluid mechanic experiments, and he measured water flowing out of a vessel. And here's a picture of the vessel right here. And as you can see, he performed experiments, and he noticed the higher the liquid was in the vessel, the faster the liquid flowed out of it. So he established a relationship between the velocity while the water was flowing out of it and the height of the water in the vessel. He looked at this situation as a change from potential to kinetic energy. So he established a principle, as you can see right here, that says as the speed of a moving fluid, which is liquid or gas, so it can be either one, increases, the pressure within the fluid decreases. This means that the relationship between the pressure and velocity were inversely proportional to one another. So I sort of like to think of it as a waterbed, like you sit on one side and then the other side goes way up, then you sit on the other side and then that side goes way up. Yeah, those are really annoying, but that's basically what inversely proportional means. So yeah, so if the velocity is high, the pressure is low, and if the pressure is high, then the velocity is low. So Bernoulli's principle plays out in basically everyday life. Like when you think of fluid, you don't really think everyday life type, but it actually does play out a lot in everyday life. And as you can see here from the picture, airplane wings have a lot to do with his principle, because due to his principle, the air moves rapidly over the top of the airplane, which is the velocity. So if the air is moving fast over the top, then the pressure is lower. And then because the air is slower underneath the wing, the pressure is greater, so it's pushing the airplane up. So yeah, basically it applies to airplanes as well. And just like the airplane, it also applies to sailboats. And a lot of people think that the way sailboats work is just the wind is pushing it along the water, but that's not really what happens. So yeah, the pressure is just like the airplane. Basically, the pressure is greater. The pressure is greater underneath and forces the boat along the waters, because on top the velocity is greater, so the pressure is greater underneath. So it basically causes the boat to propel forwards. This also applies to baseball. So now I really got you there, right? Ha. So anyway, basically it applies to throwing a curveball. You know, the baseball has stitches on it, and the pitcher, and it's sort of like curved, and the pitcher grips the seams of it so that he can throw it in a certain manner. And when that happens, the friction engulfs it and allows more air pressure on top of the ball. Because of the fact the pressure is inversely proportional, so like the waterbed type thing, to the velocity, the bottom of the ball is moving faster. The bottom part of the ball moves downwards faster than the upper part and allows the ball to curve downwards, which throws the batter off. So that's really awesome. Show you an experiment of how the Bernoulli principle is applied by using a hairdryer and a ping pong ball, and we're going to see if it can stay suspended right above where the air is flowing instead of flying off. So let's try this. So that was really cool. So basically what was happening there is, what basically was happening there is the ping pong ball was staying right above where the hairdryer is, right? So pretend this is a hairdryer. I know it really doesn't look like one. But the air is moving faster along the sides of the ball, so it's moving a lot faster over here and has lower pressure due to, again, being inversely proportional. So you really have to know that to understand this. So yeah, so basically it has higher velocity, let's just put V, lower pressure. So yeah, and the air surrounding it, so everything out here, has greater pressure because the air is not moving as fast. So this has greater pressure. And because of this, if the ball tries to move out of the airstream, the higher pressure will move it back into the airstream. So it'll stay suspended right above where the air is blowing. So that's cool. So hope you enjoyed the video, or at least learned something maybe. But this Christmas, when you're flying on an airplane to go see your grandma, just remember, Bernoulli is the one who makes it happen.
Merry Christmas. Ho, 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 ho.